Today on CodeDependent, we'll be talking about moving objects around on the screen. So in a previous episode, we had some simple graphics, a ball that we were moving from the top of the screen down to the bottom of the screen, and we just used the default easing function, the default way of actually animating that thing. But what if you want more realistic motion? So we're going to explore some of that stuff today, and there's a few more follow-on episodes where we'll be getting deeper and deeper into the topic. So first of all, let's run the application, which I call easing ball. So you can see if I click on the ball, it uses the default ease, which happens to be a sine function where it eases into this motion and then it eases out of the motion at the end. So you can detect a little bit of acceleration at the front and then a little bit of acceleration as it gets down to the bottom. And then I've got these combo boxes here where you can choose different types of easing. So for instance, we could do linear. And you can see the thing actually never changes speed. So as it moves down from the top to the bottom, it's going a constant speed the whole time. And so the other combo box I have here changes the type of acceleration and deceleration we have for each of these other items. Although you will notice that if we choose linear easing, then we're just moving the same speed. So it doesn't matter whether it's in, out, or easing in and easing out all the way, or easing none. It's basically all just easing none. But we can take a look at some of the other curves in here. So we've got a cubic ease, which basically uses a cubic function to accelerate in and out. It's a little bit more pronounced acceleration and deceleration than we had for the sine curve. So it speeds up. It takes a little bit longer to speed up, but it goes faster. And then it takes a little bit longer to slow down at the end. Now we could change these and say, you know what, I want to accelerate all the way down to the bottom. So we're going to accelerate in, and it's just going to go faster and faster for the full duration until it reaches the bottom. The opposite is we'd actually slow down the whole way. So it starts at full speed, and then it slows down the whole way. Or we could choose no easing, and that's essentially equivalent to saying I want a linear ease. I'm just going to go the same speed all the way down. So we've got some other ones in here we could try. There's an exponential, but we need to do something interesting like an in-out. Exponential is kind of like cubic. It's just a more sort of pronounced acceleration, deceleration curve. Got elastic, which is kind of an interesting curve. We'll come back to this in a future episode to get an interesting effect with. We've got bounce, which looks really, really bad with an in-out, but you get a little bit better sense for what it can do if we just choose an out. So it goes down to the bottom and it sort of bounces down there. So that's kind of cool. So there's different kinds of easing that we can have on any animation. And we can define whether that easing function is going to kick in the acceleration curves or deceleration curves or both. And we'll take a quick look at how the code actually works. I actually think the interesting part of this show is actually in the application itself and just playing with the different eases and getting a sense for what their impact is on the motion of the object on the screen. The code itself is fairly simple. So we have this bit of code here. We've seen this in previous episodes where we're just saying, okay, I have my moving ball panel that's going to hold the ball and we're going to animate properties on that thing over time. I haven't changed that code at all. I've just changed this overall application. When someone clicks, we're going to play the mover animation. The mover animation is defined here. This is the animate property animation that says, okay, I'm going to act on the ball panel. I want you to last for 1,000 milliseconds. And we're going to animate the ball Y because we're going to move the ball from the top down to the bottom. We're going to move from a value of 0 to a value of resting the ball at the bottom of the screen. And then we have these combo boxes. So you'll notice in that animate property we actually don't define an easing function, which means it's just going to use the default, which is that sine, ease, in, out that I talked about. But we're going to change that based on the values of the combo boxes down here. So I define one combo box with the names of the easing functions, another combo box with the names of whether we're easing in or out or combinations of that or none. And when one of those is changed, then we call this easing change handler up above in script code. And we say, okay, well, when there's an easing change, then we're going to define a class based on the string that they selected. So for linear, we're going to say, okay, I want the easing class to be the linear class itself. And once we've defined that for the appropriate ease, then we've got an easing type, and we define in, out, or in, out. And then we basically choose the function inside of those classes. So in Flex 3, all of the easing functions were defined as 4 similar functions, 4 names with the names ease in, out, or none, all in this set of classes. So linear has all 4 functions, cubic has all 4 functions, exponential, and so on. So all we need to do is pick our appropriate class and then plug in the appropriate function and say, okay, this is what we're going to use as the function reference. And then we're going to set the easing function on our mover effect to be that function that we've defined according to these 2 selections. And then we're going to stop the animation in case it was already playing. We want to stop it on the fly and then restart it with our new parameters. And then we're going to play the animation. So pretty simple view of how changing the easing function on an effect can change what the motion looks like on the screen. And then you can get more appropriate functions, more appropriate easing functions that match your situation. So in particular, since the ball is moving from the top of the screen down to the bottom of the screen, maybe we actually want to bounce it off the bottom of the screen and do something else with it. And that's exactly what we're going to do in a future episode. We will have a ball. If you want to check out the source code for this application, go to my blog at graphics-geek.blogspot.com.